Hey, nice to see you again. We are getting away from factoring. Yes, we are for a little while here. We are going to be dealing with functions and domain and range, something that will come into play when we're doing some interval notation and some graphing stuff that's coming up. So important lesson to get a good basis on all those things. So if you take any algebraic equation, okay, we call this a relation between what's called input and output. Now, let's clean this up a little bit, okay? So, for instance, when we're looking at this, the input value, the number I'm going to be plugging into the equation is 5, okay? I'm going to take this 5, when it says f of something, and I'm going to plug it in where the x is at. So what I do when I'm finding f of 5 is we do some substitution. It's just a fancy way of writing it. 3 times 5 is 15 plus 4 is 19. But let's take it a step further. A couple of things to kind of keep in mind that might simplify things for us. F of x is just a fancy way of saying y equals. Okay? So a way you may have seen this exact same problem written before, maybe in Algebra 1, maybe in somewhere else, would be, hey, y equals 3x plus 4. When x equals 5, y equals what? This is the exact same question. Like, why do they make it so complicated? It's one thing mathematicians just do. So when we're talking about functions, okay, because we're going to be looking at this graphically as well, actually quite a bit, we want to change up the way we talk about it. So if you see something that says f of and there's a number in here, basically all that means is plug that number in for x and tell me what the answer is, okay? Exact same thing. So maybe you jot what I have down here over here on your side, just so you've got a reference to something that you know, because I know you've seen that before. This is just going to be a little different. So I plug in the x value, okay? Input value is kind of like the x equals number. And then the output value is y equals, or sometimes we write that as f of x. Just understanding the vocabulary in this section is going to be a key to understanding what actually is being asked for, okay? Most of the time the math's not going to be hard. It's just going to be, am I actually getting the hang of what they're asking me for? So again, when we're talking about the vocab here, okay, a relation for our purposes is more like, okay, an equation. An equation where we're looking at when I mess with x, what happens to y? Okay? Actually, let's write that. How does x changing affect y? Like if I plug in 2 for x, what happens to y? If I plug in 5 for x, what happens to y? What's that relation, okay, between those? My domain is all my x values. Now that's always going to be true. In our case, that's all the input values. Okay, input and x, they're related, very closely related. Okay, more like, you know, brother, 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 sister, 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 something like that. My range is going to be all my y values, all of my output values. Once I know what all the x values are so I can figure out what y is, that would be my range, okay, my y values. And then trying to determine if something is a function, okay, is there only one y value for each x value? In other words, if we kind of looked at our relation or our equations like a machine, when I plug in a different value to the machine, do I get a different value out every time? Or is there occasionally a time when I plug in an x value and it spits 2 y's out? It's like, whoa, wait a minute, that can't happen. So 1 y for each 1 x. And you're going to see in the examples here how we can tell that's going to be true very quickly, whether it's in a chart or whether it's in a graph. So if that one kind of got you thinking, stick with me for just a second, and I'm sure we're going to get you situated. If not, it's always a good opportunity to be able to ask some questions. So our first example, okay, what does this relation look like? Well, the easiest way to do that when they give us some points is to plot the points. So x-axis, y-axis, so we got 2, 4. My apologies that my grids did not print off really well here. Negative 1, 3, 2, 6, and 0, 2. Now, it doesn't mean we got to always connect the lines on this. That'd be kind of funky with this one. I mean, we could try, but here's what I want you to look at, okay? Is it a function? Well, is there only one y value for each x value? That's a problem, okay? I can see it here too. I have 2 different y values for the same x value. So, no, we have 2 y values, and I'm actually going to write them out in the example so we can remind us of what this is. 4 and 6 for 1 x value, 2. Never can have 2 y's for the same x. That is not a function, okay? We call that 1-to-1 for a reason. 1y, 1x, okay? And go from there. Our domain and range. Now, this also is different. This is not a line. This is not a curve or anything like that. These are 4 individual points. So when I go to write my domain and range, we're going to use what we call braces, okay? It kind of looks like a silhouette of a person with a large forehead and chin and a little pointy nose. I used to be able to use a Jay Leno reference here, but most of you don't even know who that is anymore, so it doesn't really help me. You can Google him, though, and see what I mean. So the braces are when we're only going to use individual numbers, okay? And we always use x values for domain from least to greatest. Don't just copy what you see in the chart. Find the least value and go to the greatest. And you do not need to repeat numbers. If there's a number repeated several times, you only have to write it once. And then my range, it's the same thing. It's just my y values, least to greatest. Still braces because it's still points. So 2, 3, 4, 6. And if you ever have numbers listed out like this for you and you're asked if it's a function or not, here's the key. Notice there's less x values than y values. What that tells me is one of these is matching up to 2 of these, and we know that doesn't work. So if I have a chart, I see the x repeating, bad sign. I look at the graph, I can see where an x value has 2 y's, bad sign. And if I see less x's than y's, bad sign, okay? So, something to consider. Now, let's look at another one. Same idea. We're going to plot the points. Got to make sure we plot the points well. And then we really got to think a little bit here. So you're like, okay, is it a function? Now, your first inclination might be no, because see, we got 2 points in the same line again. But remember the rule. Is there only one y for each x? All my x values are different. Well, y repeats. Again, doesn't matter. One y for each x. Does each x value here only have one y value? Yeah. Oh, man, this is getting crazy a little bit. So is this a function? Yes. 1y. Oh, not 4. We're not golfing. For each x. If you have it in a chart, okay? We leave it that way. Oh, just a sec here. I got to plug in. I'd forgotten to plug in my computer here. My apologies here as we're right in the middle of getting things done, but it happens sometimes. There we go. Now we're not going to lose power. So that doesn't, though, change domain and range. And I'm going to tell you another trick when you're looking at the graph to make sure that something's a function here in just a moment. So domain, still x values, still braces. Again, for some of you, it's going to look more like just a squiggly line, but I'll get what you're doing. Again, least to greatest. Range is my y values. Again, least to greatest. And I don't need to repeat the 4. So this time there's more x's than y's. That's a good sign, because it means you're only going to be having one y value for each x. But the graph is where people tend to get messed up. They're like, the chart I can do, this I can do, but this graph, I get confused on, like, this 2 points is bad, this 2 points is okay. What's the deal? We have a test we can use for that. It's called the vertical line test. Okay? Vertical up and down line test, which basically tells us if I draw a vertical line anywhere through my graph, I should only go through at most one x value each time I do that. So if I do that back up here on example 1, I draw my vertical line, it goes through 2 points. So graphically, that tells me this is not a function. Okay? This tells me mathematically it's not. This tells me graphically it's not. But when I come down here, if I draw a vertical line anywhere through here, okay, no matter where I draw it, so let's even say we'll just draw it here, it only passes through 1 point. Therefore, it's a function. Now, it doesn't mean back up on the other one. If I happen to draw my line over here instead, now it is a function. Look around, and if there looks like a curious spot, draw the line through and see. Okay? So function or no function, vertical line test. Okay? No more than 1 point. 1 point for a function. You're like, okay, Hardy, we get the message. Okay, now, if our particular relation is continuous, notice the dots have been connected now, and we have shapes. Okay? Domain and range are going to be written in interval notation. Okay? Not the squiggles anymore, not the braces. So, let's test for a function first. I'm going to use my little pad of these. If you had like a note card or a piece of paper, if we're going to test for this function graphically, we're just making sure at any point it's only going through 1 point on my graph. And as long as it's only going through 1 point, we pass. Okay? So here, is this a function? Yep. Why? It passes the vertical line test. Okay? I only had 1 point, 1 x for each 1 y when I was putting vertical lines through it. Now, when I go to do domain and range reminders, still x values, and we're rolling from left to right. So find that point to the left. If you have colors especially, that could come in handy here because kind of watch what I do. So I find that first left point, and I'm going to follow it back to the x-axis. That's my starting point, okay, at -6. So then you follow all the way to the right side of the graph, and again, follow it back to the x-axis and write that value. So by showing interval notation, this says, hey, every single number between -6 and +6 is part of my answer. Okay? If it was the braces, I'd just be saying it's those 2 points, but that's not what I'm doing when all the lines or all the dots are connected with a line. Range, y values. Y values going from bottom to top. So find that lowest point. And again, we're looking not to the x-axis anymore. Don't do -6. Follow it back to the y-axis. -3. Find that top point of your graph. again, the y value at that point. That's the thing we got to keep straight. Domain, x, left to right. Range, y values, bottom to top. And sometimes the points can repeat for x and y. They'll just have different values. Something to consider. So then we get to number 4. And we start doing our vertical line test. And we're like, oh, wait a minute. Okay, just for an example, I'm going to draw a vertical line through here. Anywhere in the graph, I notice it's going through 2 different points on my curve, 2 different points on my graph. So what does that tell me? This is not a function, okay? You can either say it fails the vertical line test. You could say 2 x's for 1 y. I'm perfectly fine with either of those. Just got to be able to have some sort of an explanation that mathematically would make sense. And so then the last part, okay, my domain, again, is my x values. Find that furthest spot to the left, follow it back to the x-axis. So we're at -4. Okay. Furthest point right, follow it back to the x-axis. We're at 8. And then our y's, again, bottom to top. Now, it may look as you're down here like it's a little past the -4. I mean, if you wanted to get cute and call it like -4.1, you could, but I would give you credit at -4 on that. Okay, unless it's like obviously off somewhere. Like here, again, if you want to get cute, you're like, well, it's a little above 1. Call it 1.2. But if you called it -4 and 1, I'm giving you credit. Okay, we're not going to get that complicated with this. Biggest thing here is just remembering what domain is, x left to right, what range is, y bottom to top, and if it's a function or not. So one more twist to throw in. We've seen just dots. We've seen shapes that have endpoints on them. And now our last part of this is going to be what happens when we get arrows working. Okay? Just a note here for the top. Arrows equal positive or negative infinity. Infinity is going to be somewhere in my interval notation if there's arrows. It just depends on where. So let's get down to business. So we're doing our vertical line test and my vertical line went through 2 spots in my graph. 2 x's for 1 y. Function? Nope. Fail vertical line test. Okay, 2 x's for 1 y. Can't have it. Now, domain and range. Okay. Domain. Now remember, these arrows mean that graph is going infinitely those directions. So when I'm starting left, I don't mean at this arrow. Left is like, woo, off the paper, through the wall, all the places. So when we're going forever left, we're heading towards negative infinity. Now, am I going forever to the right? No. As I come in from negative infinity, I get to about right here, and I stop at 3. You're like, why are you using different symbols? Because infinity has no end. I can't say, hey, I'm starting at infinity. It doesn't end, so that gets the parenthesis, okay? 3 is my actual stopping point, not just before 3, not just after 3, right at 3. So when it's that particular spot, basically the rule is if it's a number, it's a bracket. If it's infinity, it's a parenthesis, okay? Is the easiest way to remember that. All right, range, we're going bottom to top. Bottom to top. Down forever. Didn't know you were going to get sound effects too, did you? Up forever. Infinite. All the infinity. Okay? The fact that it stops over here has no difference on how my graph is going to continue to expand both down and up forever. That's what we're working with. All right, last one. Now, here's what I would challenge you to do. If you haven't done this throughout, I would challenge you to hit pause right now on this video. You try to do number 6 based on number 5 and some of the other ones you've done here, and then start me back up and see momentarily if you've done this right. Okay. So, hopefully if you're going to do that, you've paused me and are restarting me. If not, well, it is what it is. And we're going through with our vertical line, 1 point, 1 point, 1 point, 1 point, 1 point. Okay. Past that. Yes. Explain. Passes. Vertical line test. All right, we can say this. It's 1 to 1. Okay? 1x for 1y. So now, domain and range. Okay. Left. Forever left, which again, forever left is negative infinity. To forever right, which is positive infinity, or you can just write infinity. You don't have to put the plus sign. Okay. Range. Bottom, there is a bottom this time. Now be careful. You see it right at the 2. You want to write 2. Don't write 2. You're like, why not? Because I'm looking at it from the y value point of view, which is 0. But up, forever to positive infinity. And we get that in. Okay? So your job, you kind of know what your job is at this point. Your job is to play with some of those on the identified domain and range practice. My apologies, I ended up with it twice. If you have the packets from me, I don't know sometimes what happens with this, but it happens. So try some of the practice. If you have questions, as always, let me know. Go get it done.